actually. Okay, here we go. Great. All right. Thanks so much for sticking around and joining us for our panel this afternoon, the future of cloud networking and policy automation. So I'd like to thank you for joining us, and I'd like to begin by introducing our panel. I'll start out. My name is Matthias Makowinski. I'm a research director for IHS Markit. We are a intelligence and information services company, cover a wide variety of different sectors and industries, anywhere from materials to energy, transportation, and technology. Myself, I sit in the technology division, and I cover things like enterprise networking and communications, as well as support our cloud and data center research, of which I will present some of our findings here in just a few moments. So why don't you go ahead and introduce yourselves?
Hi, I'm Doug Lardo. I'm a network architect at Riot Games. I've been working there for about 4 years. Just help make the data centers consistent across the globe and enable our developers to make awesome things.
I'm Joel Beathers. I work for Cox Communications, a cable provider here in the United States. I manage the network design team that is deploying our NFVI infrastructure for virtualized network functions.
Hi everyone, Rahul Ravlur. I'm the co-founder and CEO for AppOrbit. AppOrbit is a 2-year-old startup in the Bay Area. What we do is we provide an application data platform for customers to build, release, manage applications on the hybrid cloud very easily. And we do that, one of the aspects how we do that is by providing a policy-based infrastructure.
I'm DP Ayadevara. I'm a director of product management at Juniper, and I'm part of the Contrail business unit. Contrail business unit primarily develops the Open Contrail product, which is an overlay-based SDN solution for a multi-cloud environment.
Excellent. Great. Thanks so much. And what I'd like to do next is just present a few slides of some of the research that we've done to set the context, set the stage for our discussion today. And one of the things we hear a lot of course, is things are moving to the cloud, and some of you might already know that, have some idea about it, but we like to look at how real is this movement, how fast is it progressing. And so one of the things that we do is talk to a lot of enterprise users. Once a year, we do a series of surveys and questions. And one way to look at this is to see what are companies actually spending on cloud services. And what you can see here is the budget has been consistently moving towards cloud services over the past few years. It exceeded 10% in 2015, and by the end of 2017 is expected to reach close to 20% of the budget. So that's a nice portion. Of course, the flip side to that is 80% is still spent on in-house infrastructure. And one of the things that we're seeing is adoption moving beyond the early adopters to mainstream buyers, as well as companies making their offerings consumable as a service. Another way you can look at this market is to look at the revenues that the cloud services providers obtain every year. And as you can see here, infrastructure as a service, cloud as a service, platform as a service, and software as a service. If you combine these 4 pieces together, that's well over $100 billion in annual revenue, and expected to be well over $300 billion by 2021. Double-digit growth every year. You can see that the market so far has been very concentrated with infrastructure as a service, so compute, storage on demand, as well as software as a service. And we think these will continue to be mainstays in this market, but a lot of the growth is really coming from cloud as a service, which is an orchestrated platform where you can just load your applications in, as well as platform as a service, which is geared towards application developers. So those are the 2 high-growth markets is our expectation over the coming years. Another interesting thing that we find is that enterprises use multiple types of cloud service providers. The average here in this particular survey was 6, and they expect that to grow to about 8 by 2018. Multiple reasons behind that. A lot of services providers are very focused. They may only offer IaaS or SaaS. That's starting to change a little bit as they're branching out into some of the other high-growth areas. There's a lot of SaaS offerings out there that address some very specific needs. Say if you're a healthcare provider, there's probably a SaaS platform out there that takes care of some of the specific requirements that you have. And then this last piece is this need for local operations as well, depending on regulatory or data security, data privacy types of requirements. So you may need to have a local provider in region. So that gives rise to a number of different cloud architectures. On premises on the left side, and then off premises, the services based market on the right. One thing that we see happening there is public cloud has been at the forefront. Now we see a lot of interest in off-premises private cloud, in private cloud services, so that your infrastructure is dedicated to you and not shared with other customers. And then we see various types of hybrid models evolving here. And then this last piece I want to touch on is the networking equipment market opening up over the past few years. So one way to look at that is look at software-defined networking capabilities, where vendors are offering APIs into their equipment and allow control by third-party applications or by controllers. So if you go back a few years, a lot of this was really driven by the big cloud services providers rolling out bare metal equipment, putting their own operating systems on this. And now we've seen a lot of the traditional vendors also following suit, making their equipment more open, programmable, and letting it be controlled by, again, a controller or third-party applications. So that's my part of the presentation here. And what I'd like to do next is we have this structured into 3 different topics. First, I'd like to talk to our panel about the cloud, what it means for their business, how they're using it. After that, we'll take a look at policy automation, which is another big segment here of our discussion today. And then finally, look at intent-driven automation. So let's begin with our first topic here, the cloud. Maybe each one of you can weigh in and let us know how are you using the cloud in your business, and yeah, tell us more. Who wants to start?
I guess I'll go first. So for us, we have no aspirations of trying to take on Google or Amazon or those things. That wouldn't make sense for us. What we do want to do is get more out of our customers. So how can we provide a better experience at the home? How can we provide more services for our business customers who want all these things, but don't really like when we come in with 45 RU worth of equipment to provide services, and and expect them to pay for the power for all this and whatnot. So there's that aspect of it. And then internally, how do we provide our own customers and systems to meet the everyday business needs in a much more succinct manner?
So for us at Riot Games, we, interestingly enough, never really developed a virtual machine infrastructure. Part of it was that our game servers, if they run more than 50%, or if there's like contention on the CPU, it actually affects the tick rate of the server, which players can feel, and they interpret it as lag. So internally, we kind of never needed to develop that skill set, but application teams were coming to us and saying, like, we need infrastructure now. So we're like, well, we don't have anything to do other than we just have to give you bare metal. And they say, well, what about Amazon? We say, go for it. So in the early days, it was just about them just unblocking themselves and being able to develop rapidly. And then by the time they got done with the product, they'd bring it in-house and we'd ship it out in our data centers. But as time goes on, as you all well know, if people develop in Amazon, they want to stay in Amazon because moving their infrastructure is work. So what we're trying to do now is identify the patterns of our development teams and say, okay, this development team is doing it this way. We see other teams doing it in a similar way. So let's bring those patterns to a central team and then try and leverage that knowledge and make like a golden path and say, okay, now this works, use it, and by the way, it'll work in any data center across the globe. So we're really like leveraging the expertise of our development teams to help give back to other development teams. So in a roundabout way, it's really all about what works best for the developers.
In our case, I mean, I work for Juniper, and I said we work on open contrail, so we are enabling all these use cases and experiences. Having said that, we also eat our own dog food. What I mean by that is, a lot of our development happens on, on cloud, basically. Juniper switches run Junos. A lot of the CI/CD environment for that runs on our IT clouds, some of which are OpenStack enabled on-prem, and there are developers who are also, for example, in our own open contrail development team, they leverage AWS and Google Cloud, et cetera, to bring up environments where they can experiment with and so on. So we are on the vendor side where we provide solutions. At the same time, we are also experiencing a lot of those use cases like both Doug and Joel mentioned.
I spent many years at VMware before this, and so one of the things we saw was around virtualization. It was all around the richness of the virtual machine and the different kind of capabilities that the platform provided earlier. And so the shift that we see in the next, I would say, the past 4 years or so, is it's not really about what the virtual machine actually gives you, but it's really the access. So it kind of resonates with what Doug was saying earlier. It's really about the application patterns and how quickly can I get it, and as long as I get those different LLTs being honored by the underlying infrastructure, it doesn't really matter from that standpoint. This is where one of the things, our kind of what we are taking to our customers and what we are hearing from them is they really want to be able to really get infrastructure based on these different capabilities, right, and as quickly. So availability, performance, security, those are the different LLTs that you want to expose back up. And then have the ability to go and actually get that in a self-service fashion as quickly as possible, get visibility to the costs, and be able to govern that from that standpoint. So cloud is really, it comes down to this, ability to really consume this infrastructure, which is this infinite capacity, based on the requirements that the application needs.
Yeah, okay. Perfect, thank you. So what I'd like to do next is actually shift to our second topic, which is one of the key pieces of our panel today, and we really want to take a closer look at policy automation. What I'd like to do is first of all, I'd like to get your take, what does policy automation mean to you, and how does it relate to your operations of cloud networks, and how does it address how could it potentially address some of the challenges? So who would like to start?
So policy automation for us is one of those things that has just been a huge pain point for deploying across our infrastructure. We have many data centers across the globe. Some are running, Juniper firewalls. We got Cisco. We got IP tables. In one data center, we have all our rules on an F5. Like, it's just kind of a mess. But it's difficult to justify going and moving all those things around when it does work, and we can just kind of throw bodies at it to solve that problem. But it doesn't scale long term. So what we ended up developing is actually an agnostic language that is really about app A talking to app B. And we put that into GitHub, and our developers can go in, make pull requests against each other's repos, and use that as a mechanism to request access from one app to the other. We then run a process that grabs all of the JSON with all the app-to-app policies, and then compiles it into API calls, which actually talk to Contrail. Then Contrail just does its thing and then spits out into the vRouters, and then all the policies live across the entire infrastructure. And since we can put Contrail on top of any infrastructure, now we have a unified policy framework that works in our local data centers, works in cloud, and pretty much anything that we are going to come across. So it's all about just getting developers to be able to self-service, but also not have to know IP addresses or any of the down and dirty details of infrastructure. So we've estimated we've saved like 3 years worth of man hours just alone, after implementing the system. And things are way more secure, way more consistent. And also because it's infrastructure agnostic, like it's just app to app. Not that we would ever throw out Contrail, but if we did, then we can just write a new compiler for something else. So it also protects us in a way from, vendor lock-in.
Mm-hmm.
So for us being a service provider, we probably have more firewalls than you'd expect. I think we have in the neighborhood of maybe 140 firewalls, pairs. Crazy. So sometimes it's I'll have my firewall talk to your firewall type of thing. So we have applications that have to be double natted and also have to transit yet another firewall. So you can imagine this is painful for anybody. So what we've really noticed is I'll piggyback on what Doug was talking about. It's about an architecture. Can I get to a place where my policy framework is modular and portable? And then can I layer on a security analyzer that will say, okay, you have A to Z, you transit 3 firewalls and maybe a load balancer. Will the requested connectivity work? And if the answer is yes, have at it. If the answer is nope, it stops at the 3rd firewall, what do you want me to do? Do you want me to fix it? Or do I have to kick that to our security team and say, hey, is this even appropriate? And they can answer in a timely manner. Ultimately, a lot of this is about ticket intake and managing tracking of changes and things of that nature. Layer on top of that, we are moving to a regionalized firewall model where all hosts live in their connectivity domains, and they can have ubiquitous east-west within their domains. How do I stop that? Well, this is great. You can do that in all this connectivity now that they don't have to jump through all kinds of firewalls, but how do I keep them from attacking each other? Well, so this is where we have SDN control coming into place. We are leveraging it to fine grain say, well, this host can talk to these 7 items on these ports and no more.
So a couple of things. So policy at the most fundamental level is the rule, right, that you want to enforce. And you want to do this, there's a couple of reasons we'll go into why this has become a bigger issue than not. And it is like cloud or big data, right? It's become one of those terms where you have policy at different layers, actually. So you have policy for data, you have policy for networking and security, you have policy for being able to even intend availability, the placement of the application. But the one thing that actually is really apparent that comes up is when you want to define your intent, and you want to be able to go actually then configure that intent, right? So you define what your application needs to be able to talk to, then you configure that, and then you want to be able to manage that, right? So you want to be able to enforce against that policy. So the approach that we've taken is that when you actually take a look at this policy from a networking standpoint, a security standpoint, specifically is when you deploy an app, this is where it actually gets really complicated, right? Because you've heard couple of really great examples around firewall rules of being able to set up, even for example, load balancing. Like if my application is scaling, how do I actually, until what? And there are now you set up business policies to say till what level do I scale that up, right? At that point. So what we've done is from a networking and security standpoint, is very simply define at an application level, be able to say what are the different components that can talk to each other, what are the different ports that are exposed, what are the protocols that are exposed as well, the direction of traffic, and then that actually changes even in the life cycle of the application, because you want maybe a more restrictive policy in your production environments, but when it goes into maybe a development or a staging environments, a more permissive policy which doesn't necessarily cost as much is actually acceptable at that point in time, right?
Sure. So this is a problem in your 4th, right? All your points are done. No, just kidding. Just to wake up people. No. So on a serious note, right? Typically when we talk to our customers in the conversations, there are 2 to 3 fundamental challenges they have that they bring to us, right? One, for example, in the case of app developers or application companies, right, you have the developer workflow, and then you have the administrative workflow where the CISOs and the network admins want to apply policies and make sure you're meeting your regulatory requirements and compliances, et cetera, right? And the first problem statement is how do I automate policies in a way that I keep the developer workflow independent of the policies I want to apply so that I don't have to every time go get the app config to be changed, et cetera, right? That's one. The second thing is, as we all discussed already, I mean, people have a hybrid cloud environment or a multi-cloud environment. So every time you want to apply a policy on a particular environment, you should be able to take a single definition and be able to apply it, right? You don't want to have a policy for let's say, a VM-based infrastructure, have a policy for AWS, and so on. You should take the same policy, as Doug mentioned, like an app kind of an abstraction, and be able to, we call it, compile it locally to what is specific to that infrastructure, right? So that's one. And then the last thing is, again, I think both Joel and Doug mentioned, you have multi-vendor environments, right? And so are you going to use 5 different manageability panes to manage these, or do you want to use one, right? So these are typical problems that we have heard from our customers. And through Contrail, through various features, we try to address these so that you have centralized policy definition, and compilation happens locally so that it's more infrastructure specific. We use a lot of tags and labels so that things stay abstracted, right? So these are some of the key things we are doing and to address the 4 problem statements I mentioned.
Nice, thank you. So I'd like to remind our audience, or just let our audience know, that we are open to questions. We have 2 microphones set up here. If you have a question for a panel, feel free to step up and ask your questions, and we'll get them answered, hopefully. So with that invitation out there, I have some other questions for you. So one of my questions was going to be, have you implemented policy automation? I think that is, it's clear that many of you are already down that path. So perhaps you can talk about some of your experiences and maybe what were some of the challenges, some of the pitfalls, what's some of the practical advice that you can give to our audience here based on what you've learned?
Sure. From our perspective, right, so when we started off with Open Contrail as an SDN solution, it was meant to be more cloud native, which means we started with virtual endpoints, right? So we did we understood that policy, is a critical part, and so we implemented. And at that time, this is more than 4 years back, right? So for us, the abstraction was virtual network. I mean, we still abstracted it to an entity, and that was virtual network. And through the years, through a lot of interaction with SaaS providers, telcos, et cetera, what we learned is now we have to further abstract it to the app level and be able to so that, like I said earlier, right, people don't have to worry about what network infrastructure is underneath to define my policy and IP addresses and all that. So abstraction is very critical, and scale is very critical. How you define the policy and where does it get interpreted kind of has a direct impact, because these days it's more about zero trust, and so a lot of cloud environments are more about whitelisting, which means explicitly you're allowing communication, and so the scale is going to be pretty huge. So how you define and are able to compile and apply these policies is very relevant to kind of how our policy framework has been evolving. And yeah, hopefully we are meeting the needs of our customers with that.
Just to add on to what DP said earlier as well, is there's a couple of things. One is that you need to stratify this. So essentially, there's different layers, as I mentioned, where these policies need to be applied. And so, for example, you could say, I want to set up my parameter policies for my production environment. But then as the application is deployed within it, it actually gets its own policies that are defined with it as well, right at that point. So now then you have 2 different policies that are being applied by 2 different users as well from that standpoint, right? The second part is the big change that has really happened, I would say, is really the pace at which applications are being released and that's what has made it a lot more difficult now, right? So earlier you could actually set it up in a way that was pre-configured an environment, and then you're deploying an application within it. But now, let's say this application is being made up of these different components, and you introduce a new one. Now you need to actually go in and update your policies, right, at that point in time. So how do you actually enable that from a self-service fashion so your development teams can actually go define that, and that actually makes its way across the application lifecycle to the ops teams as well that actually are going to go and enforce it. Then they know what the intent was, and they can actually measure against that intent, right, from that standpoint.
Yeah, just had a question for you guys as far as if you're going to do any automated setting up your connections between your networks. Have you thought about auditing the connections that have been set up to make sure everything's correct? Because my company, we kind of have the same thing, and I'm going to be in charge of doing the auditing. And I just want to know if you guys had any ideas, if you do have anything in place that you're doing that right now.
So I'll go first on that. We have a tool that we've been leveraging in the lab extensively over the last 8 to 12 months, and we're starting to deploy it in production. Its current mode of operating, it can do several things, but it's currently what we're doing is leveraging it to do exactly what you're asking. It goes out and says, is this policy ever used? If the answer is no, then we schedule it to delete it. If it's used maybe 4 or 5 sparingly, then we take a look at it and say, well, why is this used so sporadically? Can we just migrate this to, is our security posture too granular? Can we just kind of lump it in with another thing that kind of looks the same, walks, talks, and acts the same?
So we put everything in code as like that app-to-app language, right? But like in some parts there's still IP addresses, largely because we have legacy environment that we need to talk to. So there are just times when you need to talk to an IP address. So since everything is kind of joined and collected together in one giant GitHub repo, it's all JSON, and the security team can actually pull that whole repo and then just do like anything they want basically on those policies. So that's something they're looking into, is like how often do they do it? Because they don't want to be blocking, they want developers to be able to do what is best for them, and then kind of every once in a while just be like, so you didn't really put 0 whack 0 in there, did you? Like that's kind of a little too broad. And one other thing that's nice about GitHub actually, that is really tough to find in traditional firewalls and security appliances, is GitHub has this great feature called blame, which is like the perfect name, right? Because like you go into GitHub and you see exactly who committed that line, and then you can follow up with a person and say, okay, what was your intention behind this rule? Because if it just gets to IP addresses, like you have no idea what they want, and yeah, maybe the flow works, but maybe that's not even what they were supposed to trying to do, and like we're getting connections in from other parts of the world that are like RDPing into our systems. Like, it's part of it, like but it's not like, should this be here, and can someone answer for the policy? And I think a lot of security is just being able to figure out like who ultimately owns this policy, who's ultimately responsible, who has the final say, and what was their intention. Because all too often security policies they always seem to grow, and they never ever shrink unless the rule is never used. So like you just kind of over time you just get more and more corrupt in the environment. So being able to every once in a while kind of run a compaction strategy on it with the sense of intelligence that ties back to a human is really valuable.
Excellent. Thanks for the question. So any others, feel free to step up. And we talked about, okay, here's one. Perfect.
Thanks for the talk. I have 2 points. I want to know what's your idea about it. One is, so you mentioned application to application. So first thing is application. What we can think of currently is still based on IP addresses, but what are the other identities, or how to manage those differences, how to model that? The second point is, since we have this hybrid kind of deployment, you have a legacy system, you have SDN, you have public cloud, and you have maybe a firewall. So even if you have application-to-application modeling, then how to manage those hybrid systems, how to converge those?
Yeah, so the first one is like, how do you get around IP addressing being your source of truth, basically? So what we did in our Contrail deployment is we said there's one gigantic system, or one giant pool of IP addresses, and every time you spin up a new instance of something, like you just get a random IP address, and that's just the world that developers are going to live in now. So if you want to identify that application, you actually do it by the virtual network name. So we have a system that says your network name is actually named after your application. And we have a format for that makes everything standardized. So when you look in the Contrail like debug view, you can basically see like VNA talking to VNB on this port. And then as apps come and go, they always fall into that VN and then inherit that policy. If we need a fixed point, we rely on DNS. Or there's also a concept, especially for like public, like whitelisting coming in from the edge. Like sometimes you just need to have it. You can set aside like a special range and just say like, okay, this is the exception. But that's a floating IP address. So like that, you'll come in, you'll hit that, and then that does a NAT, which will hit the actual. So that floating IP will stay static, so someone can hit it. But you know, behind the scenes, it's always changing IPs. What was your second question? The
second question is you have a different kind of system. You have legacy system, you have
okay,
firewall,
I remember.
SDN, and public cloud.
Yeah, so we implemented a system called In Our Cluster We Trust, which what we said was in our SDN is where all the policies live, and all of our SDN clouds come from known address spaces. And the In Our Cluster We Trust says that all the rest of the systems should just trust that the clusters are filtering on outbound. So the rest of the systems that are external to the cluster, you have to manually go and define, like, I want to reach it. So it's kind of shifting the policy from the external device closer to the source, but there's still a point of enforcement, you know, in between the applications. So there's one rule on all of our devices that say, like, you can permit these 10 addresses, or 10 WAC 8s or whatever we use, WAC 16s, as a summary, and then that way we'd never have to update those legacy devices anymore.
Yeah, maybe my point is you have this different kind of system, so the enforcement mechanism may be different. For example, in public cloud, maybe you cannot use like neutron security group to do that because, so I want to know how you consider this.
So I can take that one, right? So basically the way we do it is based on tags and labels, right? Now, for example, if you have Contrail as the SDN across all these environments, right? What you can do is when a VM comes up, for example, it comes up in a particular, let's take the example of deployment and site. So it comes up in, let's say, test deployment, and the site is, let's assume it's Boston, or hypothetically, right? So when a VM comes up, we know where the location is, and so these tags get applied there, yeah? So now what you're saying, now in your application, now when you're defining policy, you can say, I want app A to talk to app B, but only if their deployment matches and they are on the same site, right? Something to that extent. So that abstract policy goes down to, let's say, your respective cloud environments. And Contrail knows that these tags, right? When a VM came up, it knew it came up in Boston and so on. And when you're getting in traffic in, or when you're really applying the policy, you use these tags to match exactly where things are coming and all that stuff, right? So tags and labels are ways you can abstract out the real infrastructure underneath. So you don't necessarily have to do it security group based, etc.
So the tags actually you are carried in the packet header, or?
I think we're now going into more implementation details. Probably we can have a conversation on the side, but we can talk about that, yeah.
Okay, thanks.
Okay, thanks for the question. So another topic that we like to touch on, we're getting towards the end here. You talked about intentions. Now, this is not exactly the same thing here, but one of the things we said we would cover is intent-based policy. So I'd like to hear from our panel, what can we understand by this term, intent-based policy? And yeah, let's start there, and then we can look at, implementation. How do you actually go about implementing it?
So as I said earlier, a big part of intent is actually describing application behavior. So for us, the way we actually define this is the application intent is actually captured in a textual file, right, which describes what the application needs in terms of application-to-application communication or even external communication to external services as well. And we do this by essentially that definition needs to be in a portable fashion, right? And now that when you deploy that particular application at that point in time, that intent needs to get plumbed down into different configurations like setting up your firewalls or setting up your networking routes as well from that standpoint. And then you measure against that intent, right? And then so that intent is what you are managing at that point in time to make sure it is always being enforced.
So I'll piggyback off of that too. We have a team that used to essentially just kind of decide where things go. Oh, this is a web server, okay, it has to go over here. This is a database, it goes over here. Oftentimes we have a MIS network that's, oh, it's 10/8. We'll just shove it in there and deal with it. We are rapidly moving towards more of a, like what Rahul was talking about, of identifying, okay, this is a web server. Well, is it an internal web server? Is it an external web server? And then developing policy around it and saying, okay, well, if it's an external web server, you naturally get X policy. And no matter where you go, this policy follows you around, no matter where you live. If it's in our data center, if it's in public cloud, it just follows you around wherever you go.
Yeah, I think you guys said it well. For us, just like, what do you want to happen? And we will take care of the details. So as long as you're not being too descriptive, like you're just saying, I want me to talk to this and maybe talk to a load balancer, and that's it. Like, then it frees up the operations team to just enforce that any way they want. So it really just makes a good level of abstraction, because that's all application developers really want to say is like, I need to talk to this, like, make it happen. Like, so, and we don't want them specifying IP addresses and things, because they're probably going to not have the knowledge to do that. Or if they do, it's going to be difficult and painful for them. So it's just a good way to kind of that separation of concerns and allow each team to do what they do best.
From tools and vendors perspective, right, couple of things that are essential to help our customers realize intent-based policies. One, you're defining a policy. Now, do you really know if that your intent has actually been met with the policy, right? So there are things like capabilities like you can add where you have a learning mode, where you're simulating your policies and making sure the intent is actually being met, right? So that's one of the things you can do as tools. And secondly, now, where is this intent coming from, right? Given the world we are in and how it's evolving, with analytics and monitoring, a lot of your policies are going to come through, like, there's an anomalous behavior detected, and an automatic, the analytics tool or monitoring tool may want to impose a policy, and so it may basically just do a self-remedial policy invocation, right? So in those cases, your APIs should be actually flexible enough to capture an intent and so on. So from a tools perspective, those are two things I would say.
Okay. Perfect, thank you. So we're getting near the end of our session, so perhaps we can end on a last question here, sort of looking ahead into the future. What does the future hold for policy automation? And you guys all come from very different backgrounds here and have different, maybe you're working on something as a vendor, or perhaps as a user, service provider, you have certain things on your wish list. So what's next for policy automation?
For me, I hope that the community drives toward a unified policy language. If you think about it, it's really not in any vendor's best interest to come up with this, because they all have their own ways of doing things. And if we want to be able to be portable across vendors, and we really want to enable our developers to just simply state what they need and then free us up, that kind of has to come from us. It's a huge challenge to interact with devices today that are, one may speak in firewall zones, another one has access groups, another one has policy statements, another one it's just IP tables. It's just all over the place. And I don't think those are ever going to unify on their own. But if we create as any, I pick on software developers sometimes because they want to solve everything with like another layer of abstraction. But like I think this is probably like just like network engineers, like any problem can be solved with another tunnel. So it's like maybe we should just tunnel the abstraction layers and oh, it's contrail. But but like that's what I hope is that because right now the primitives that we use in OpenStack are they're very much like here's an ACL and they kind of still speak in that language. So I would like to see another kind of project or effort that speaks from a different perspective into the system that will take in that and then allow maybe another compiler somewhere in the middle to actually affect the policy.
So we want to do two things. We want to leverage centralized policy enforcement configuration to free up our operations team. We're pretty much at like 125% of what we can do. We've been told you're not getting any more FTEs, so figure it out. So what's the next evolution? And it's essentially kind of what Doug is talking about. Of well, we got to start automating this and get this day-to-day off our back, and free up our guys to do what they really were hired to do in the first place, which is solve head-scratching problems like, wow, why did it do that?
So I think it all comes down to really, scale, speed, talent, right? So what you're going to find is, earlier we had a server to admin ratio of probably about 10 to 1 with virtualization that went to 100 to 1. And now I think we're going to see the next level of magnitude, right? And the only way you'll get there is with policies because you need that to manage scale, right? And the issue you're going to really face is there's a talent crunch. You just can't find really good people, right, to go do that at that point. So what we're going to find is we're going to get more and more sophisticated in terms of applications. There are been some great talks here as well about how applications are going to move closer to the user for performance, to essentially satisfy performance QoS. There's going to be for cost arbitrage, you'll be able to move applications to lower cost infrastructures as well. And all of this is going to be automated, right? And so what TP was talking about earlier about things like machine learning, and there's a lot of different aspects that need to get factored into creating these policies automatically as well. And so when you kind of like take these business factors in mind and the technology constructs are all there, it's just a question of how quickly can we actually get to those different proof points.
And lastly, I think I would summarize it to two things primarily from our perspective to help our customers realize exactly what they have said here, right? So the right level of abstraction is important, and how you can translate that abstraction to be able to enforce policies on a variety of infrastructure. So be infrastructure agnostic, but at the same time, when you have a public cloud or when you have on-prem cloud, be it OpenStack or whatever, be able to apply that policy in these diverse environments, right? These two are the most critical things from our perspective.
Perfect. Well, thank you so much to our panel, and also thank you to our audience for sticking around and asking your thoughtful questions. Really appreciate it. And this concludes our session today. Thank you.
Thank you.